Hey, how are we doing, everybody? Good morning. Lots of meetings today. Checking my volume levels. I think they're good. So it shows sometimes it shows my volume levels are higher than I think they should be, but I don't know. People say it sounds fine and the volume levels are good, so we'll keep to that. Maybe let's go a tiny bit down. There we go. People have to tell me if I'm too quiet or not, but we'll see if anyone shows up right here. We might take a look. What packages have we not looked at in R lately? We got so many new packages. We were looking at Feather last time. I sent out an announcement to the Discord. We'll see if anyone said anything. No one said anything on the Discord. We got general chat. General chat up. People are saying, is there a Kahoot? Do you use the key or do the first key? I do it with the key. Yep. People are helping each other out. Someone tagged me, it looked like. Yep. People are explaining. Good stuff right there. I thought I saw I had a tag in this one. Discord suggestions. People are saying music. People are just talking about Vampire Diaries. People love some Vampire Diaries. Good old Ian Somerhalder. Let's see right here. Is anyone in the chat? No one's in the chat yet. Brian's just hanging out by himself, looking at the Discord right now. New mention in gaming. People are talking a bunch about gaming. People are talking about Just Dance. Just Dance is really cool right here. Mario Kart. Some Double Dash. Toon Link. People talking about main. Oh, man. As long as you don't main Kirby. Kidding. Kirby mains. Too many people maining Kirby. So, people talking about sports, PlayStation chat. A bunch of people are just socializing, which is really awesome. People talking about PlayStation 2K. Good stuff right there. Yeah, wow. Lots of chat. Chase has 5 booms. Pretty crazy. Put on a Bachelor. Oh, man. Everything's taken off right now. People are chatting it up. Maybe people are just relaxing and talking on the Discord. I love it. Good stuff. Let's see. Got members joining in. People joining in yesterday. Wow. So got a bunch of people joining in on the server. Authenticating. Good stuff. If you join in the chat right now, say, hey, I'm just kind of checking out the Discord. Let's see here. Force 434. Dr. Lou is helping out. There we go. Dr. Lou is helping out, answering a bunch of questions. Awesome stuff. After the midterm. Basically, simple regression through model building. What does the take-home final cover up to, and what does the proctored final cover up to? I think this is the question right there. Is anyone in the chat yet? No one's in the chat yet. Will there be activity review? Yep. I should be able to do that today. Daniel, do that. Maybe we'll do that during class. You know what? We could do it during class. Could do it during class. Thoughts on that? Could work. Get it done during class. That's a good idea right there. No one's here yet right now. We could do it right now. I'm streaming right now. We could do it. Could work through. Let's see. We've got like 30 more minutes, but I think it's just such a quiet day. Everyone's getting ready for finals right now. Such a quiet day. Such a quiet office hours. End of semester office hours right here. Looking through. Oh, I didn't realize that's a plot right there. Let's see right here. Let's go over here. Getting so many things. Just doing some organizational stuff right here. This is what I do in the background. You are seeing the background where Brian answers emails, replies to things, and gets everything organized right here. If you join in the chat, feel free to say hi. Imagine everyone's like working where everyone's like, oh, done with all my work for the semester. So this is me working away. Does that work? Can I use it? There we go. I'm just checking the chat periodically, see if anyone joins in the chat as I reply to messages. The means. There we go. If you join in, feel free to say hi. Go reply there. I tell you, using Discord is so much easier. There we go. Good question right here. Tricky question right here. Check. There we go. Fun times watching Brian type away. Well, we'll see if more people join. It's such a slow morning. No, we need more coffee. Just getting caught up on emails here. If you join in, feel free to say hi. I need like a thing on the screen like, if you join in, say hi. Join in. Getting caught up on all the emails. I need to create more rules for stuff. Oh, does it end? Okay, wait. Okay, let's see here. Let me send out a big email. Oh, we got a big thing for 201 right here. see. No one's in the chat yet. No. We might be getting bonus for 201. That's really good news on that front. Last call in Corsi Mouse. December 2nd. So we got time. We got time. I'll be mentioning that in 320 today. So we got a bunch of time. 320 we'll hear about that. I'm just streaming on, I think I'm streaming, right? Yeah, it says I'm streaming. So we'll see that right there. That's good stuff right there. Good stuff. Cyber Monday sales extended. No way. See if there's any other big important things. Oh my gosh. Sometimes my emails are very interesting. Hey, what's up, Kayla? Yeah, let me hop in right here. Yeah, Kayla, let's do this. Sorry, I was answering emails right there and I see so many interesting things. Rachel and Kayla, great to see you. Student wrote me a very interesting, fun email, and I'm just like, look at it. I'm just like, what's going on? That's craziness right there. Okay, so getting everything worked away right here. Let me hop over to the main screen. What do we have going on? What should we do right now? We're just streaming away right here. I'm streaming away. That's what we do. Oh my gosh, we're all gonna wake up. We're all gonna get that final cup of coffee. What questions are they? Oh, Rachel says they don't have any questions. Kayla, how'd your break go? We talked yesterday, I think. So, Kayla, here's some good news. Kayla, I think, is still here, right? I'm on Top Chat. I need to get off Top Chat. It looks like we will get bonus. I can't say we will. I can say it looks like. I'll always be honest in how I think things look. I might try to fix my audio. I'm all for review always. Yeah, we should do some review. Kayla, do you want to help me on my audio real quick? It keeps saying that it's like, how does the audio sound right now? Too loud, too quiet? Caleb, what do you think about the audio? If you want to tell me about the audio, because these are things I can't. I might do a little bit of audio checking with you right here if you're okay with that. Like, the only way I can do this is during a live stream, and then I don't get to hear it. Like, too loud, too quiet, it's perfect. And then we'll do a review question right here. And thank you so much for putting me on the spot to be like, can you help me make sure the audio? Because it keeps saying I'm peaking. Like, peaking is when your volume levels go too high. The audio thing keeps saying like, oh, you're too high, but I think it's good. I think the volume levels are good. You can, if it sounds a little, you're great. Everything's great. Good. I don't know why it says peaking. Threshold attack. Like, I'll show you what one of the audio controls I have looks pretty crazy. I'll pull it up right here. Let me show you. No, we'll do a review. These are all the parameters I can control for my audio right here. Like, this is everything. All the different things, and then you have to turn up with it. And so I see it that way, and then I also see like, see, watch this, loud. Oh, it's not peaking. Oh, I'm sorry. You're listening. You're like, Brian, come on, man. What you doing? So I'm watching the audio levels, and it's not peaking anymore. Maybe it was on the other screen. I don't know. What am I doing? I don't know. Too many things, too many dials and knobs to turn. That I'm just like, get it all figured out. Okay, let's do a review question right here. Okay, so Kayla, do you have a specific chapter, or should I just come up with a random review question? What do you think? Random chapter. It is like a rocket ship. There's so many dials and everything that I have buttons and everything to press, like different like Stream Deck stuff and everything. Just literally, I'm at the helm of a rocket ship right here. Yeah, no, it's the random. You know, we like some random right here. That's how we roll. Let's do a random question. It's so good. Thank you, Rachel and everybody. Let's throw some 500 points out here. Mubot's awake, I think, in the background there. He's always chilling out. We'll have some new additions next semester. That's what I'm always excited about. I'm always excited to like make new things. Mubot came about last year, I think, at the start of January. Commissioned him, and he exists. So does Evil Mubot. You know, if you pay for some artwork, you got to make it a double thing. So you can have Mubot and Evil Mubot, so they can trade off spots right there. Okay, let's do a random question right here. And let's try this right here. So let's do this. A little bit longer of a question right here. It probably wouldn't be presented to you in this way, but can you tell where this question is going, Kayla, and what technique we are going to use? Like maybe this is a tools and techniques question right now, and so we're just kind of covering a lot of bases by saying, okay, what tool or technique are we going to use? So the first question here is, what tool or technique would you analyze? So the first question I want to do is what tool or technique? Then we'll start to go through that. Not what graphic. Oh, that's the graphic next. You got it, Kayla. You got this. You got this. You're seeing it. So you identified it's two categorical because the one categorical variable is did you go to the review session, and then the other is did you make an A or not make an A. Yeah, it's chi-squared. 100. Kayla, you got this. You got this. Just keep thinking like, okay, it's two categorical. That's chi-squared test of independence. So what graphic would you make to what graphic would be used? What graphic would be used to analyze this data? So what graphic would we then use to analyze this data right here? So think about what graphic are we going to use? What graphical display would look at this data? Which if it's chi-squared test of independence, then we should be thinking, well, we would see it visually via this. Visually, the visualization is going to mosaic. Yep. You got this, Kayla. I want to see all that confidence. Be like, boom, 100 points right there. Got it. It's the mosaic plot because that's how we visualize a chi-squared test of independence to look at the differences in the groups. So we could solve this by hand right here, which is not going to be too crazy. Let's go ahead and draw out the 2x2 table and kind of do a little solving by hand here. See if you can get some of the values. We're given the values that 40 students attend the review, yes. And it might actually be, let's just use that anyways. And then the no is 40 students. And that's 80 students total sampled. And then we have here of the 40, so we have A and not A. And of the 40 students who attended the review, 30 made an A and 10 did not make an A. Of the students who did not attend the review, 22 made an A and 18 did not make an A. Pretty good numbers right there. So then this would be 28 students, and this would be the remaining 52 students. Okay, so I might be able to figure out some of these in my head right here, because now what are we gonna solve for next, Kayla? Now that we have the observed, what are the steps for the chi-squared? Now that we have the observed to solve a chi-squared, next we're gonna have to solve for the what's with the chi-squared. So think about the next theoretical thing we need to get the whole chi-squared test statistic, because we're going to do the chi-squared test of independence, and the whole point of this is to find the chi-squared test statistic. So we need a chi-squared test statistic. Oh, no. So the chi-squared is the working backwards from the chi-squared test statistic. They come from the sum of the cell chi-squareds, and the sum of the cell chi-squareds are the observed minus expected squared. So here, let's go look at the formula sheet. You've got the formula sheet right now. So let me go to the stat. Oh, you know what we'll do? We'll put it in the chat for people to see. We'll go to review 3, and I want you to pretend this is the test. And once again, the test would kind of prompt you for certain things. I want you to kind of I want you to figure out a system to go through this, a methodology to you go to, okay, well, let me look at my formula sheet here. So here's my formula sheet. You see, I know I'm using the chi-squared test of independence. What do you think are some things we could now figure out for this? So just be like, we could probably figure out this. Just talk me through it a little bit here. Right now, we have the counts, which show us how many observed individuals we have. These are the observations, as in 30 students attended and made an A, 10 students attended and did not make an A. So now from here, we probably want to go and get our what's. So what do you think could be something we could find right now? I'll give it a moment, let you think it over. So we have the observed. So we have the observed. The observed are what we're seeing right here. The observed are, that's not the observed. The observed are these amounts. That's how many we see. Like I see 30 students went. There you go. You got it, Kayla. You got it. 100 points. Yep. The expected. So we have the observed. So let's put an observed over here. We have the observed. I'm asking you these questions. I do want you to know at a higher level, Kayla, not the like prompting you questions. I want you to be like, okay, if I have the observed, I could get the expected. So row total times column total over grand total, exactly. And so when we do this right here, we actually only need to take, it should be, if I am correct, there's 52 students there. I think the answer is going to be 26, 14, because I made the numbers nice. So to solve this, it'd be row total times column total over grand total. The formula is row total times column total over grand total. And I made my mathematics nice because 50% of students went to the review. So now I just take 50% of this because that's basically what you're doing. It's 1/2 times this basically. Like imagine this, Kayla, right here. If you just take this off right here, do you see how that would reduce to 1/2? Like, does that mathematically make sense? Like 40 over 80 is 1/2. Does that make sense? Like just a quick YRN in the chat. Just 40 over 80 is 1/2. This right here, this formula right here, this 40 times 52 over 80. And so I solved it in my head because I know 40 over 80 is 1/2. So I took 1/2 of 26. Does that make sense? Show me the formula. Yeah, I did the math. Yep. Sorry, I did it really quickly. Kayla, show me the exact mathematics to solve for this. Show me the exact equation to solve for this. No, good thing. Someone's watching this or watching this in the future to review, and it's like the exact question you have. How did I solve for 14 right here? Like, what is the exact mathematics? Like, the exact mathematics to get this would be what? So how would I solve? Try solving that formula. These are all the expecteds. So what is the exact mathematics? I'll give some hints right here. Row total times column total over grand total. So the exact mathematics, I'll start typing it while you're practicing right here. The exact mathematics would be 28. Exactly. And the reason I can solve this really quickly is because that right there solves to what? Okay, like just look at 40 over 80. What is 40 over 80? I'm doing some quick mathematics in my head, but don't worry about doing the quick mathematics all the time. But the reason I was able to solve this is because 40 over 80 is what? So you can, the way mathematics works is you can kind of section that off. It's 1/2. So that's 1/2 of 28. 1/2 of 28 is 14. So that's how I was able to quickly solve it. And because I purposely made it a 50-50 split so I could quick solve it. But does that make sense how Brian quick solved that in his head? But if you do the formula right here, you will get the same number of 14. So it's kind of worth it if you think through it and you get an answer, then you're like, okay, this is what I should get mathematically, and I get 14. And this is for students who do not attend the review. We expect 14 of them to not make an A. Now that we have the expecteds, now that we've done the expecteds via the formula in red right here, what do we need to do with our expecteds and our observed? What do we need to do? So what is the next step right here with the expecteds and the observed? We'll go here to another computation matrix. Yeah, exactly. I would do the formula too. If I'm on a test, I'm going to double do it. I took the SAT twice, and the first time they said, "Where's your calculator?" and I went like this, and then I did all right. And then the second time I brought a calculator. She said, "What?" And I said, "It's my brain." And she was just like, "Okay. So you don't have a calculator?" It's like, "It's my brain." She's like, "You should bring a calculator." Gosh, I haven't thought of that's so arrogant of me. And the second time I took it, I brought a calculator. As I needed to take a second time. The second formula is the observed minus the expected squared over, and it's quantity squared because we're squaring the difference right there over the expected. And these are cell chi-squareds. So this is the cell chi-squared, which is basically how far are these numbers apart. So we're going to go to like these 18 and 14 right here. So it'll be 18 minus 14 distance squared over, and the observed minus expected squared over expected 14. It's going to be a little bit bigger than 1. It's going to be 1 point... I should know what that is. 1.125. That'll be 1.125. So let's take this formula, kind of move it. So we're talking about this cell right here specifically. And that cell will equal to 1.125 if I'm not mistaken. 1.125. Does that make sense? Yeah, and then we're going to do that next here. We're going to do that next. Yep. So we need to find all of these observed minus expected squared over expected, every single one of these. So I think they all have a difference of 4. Does that make sense? They all have a difference of 4. Did I grab the wrong expected? Oh, I was doing this bottom cell. Up. That goes there. What am I doing? That goes there right there. So sorry, this is the cell in the bottom right corner. And this cell right here would still have the same difference. I'll show it mathematically here. It would still be 1.125. So that's, once again, observed of 10 minus 14, square this, divided by the expected of 14, and I cannot do mathematics. 1.1, because it's a 7th, I believe. Yeah, so it's a 7th. Brian can't math. That's a theme of the class. 1.143. 1.143. I believe that's the number right there. Yeah, no, we'll find all the cell chi-squareds. 1.143. Yep. And so now we have to take and, well, let's find the other one right here. So, Kayla, take a moment. See if you can find the other cell chi-squareds. I know what it is mathematically. So what's the other cell chi-squareds right here? You need to take the observed of 30 minus the expected of 26. So that's a difference of 4. Square that, get 16, and divide by the expected 26. So I just kind of said the equation. So take the observed minus the expected, square that difference. So it's 4 squared. And then divide by the expected. So don't just tell me the fraction. I'll do the fraction here in a second. So what is the answer to the cell chi-squared of that one? Some R data right there. So what is the cell chi-squared for this one? I believe that sounds about right. Yep. So let's do it fully right here. Great job, Kayla. Observed minus expected squared over expected, and that's it right there. Yep. And so then, Kayla, what do we do to all the cell chi-squareds? What do we do to all the cell chi-squareds? So what do we do? No. What do we do to all the cell chi-squareds, which is on the formula sheet? We take all of our cell chi-squareds, and we do what to the cell chi-squareds? Which I think we add them up. Exactly. So this gives us the chi-squared test statistic. It's basically the sum of all the deviations, because these are like individual cell deviations. So then we get like a full quantity. I'm going to times that by 2, and then add to it 1.142857, I think it was. And then another 1.142857. There it is. So this is the total. Oh no. Oh no. This is not looking good for my reviews, I'll tell you that much. Because I know how chi-squareds work. You're gonna be counterintuitive right here in this one. So that's the chi-squared test statistic. Kayla, great job. 100 points. You're doing it perfectly. Yeah. So now we need to graph this. And to graph this, I have to know what for the chi-squared. To graph this, you have to know what about your chi-squared. Let's go back to the formula sheet. To graph this, you would have to know the what for the chi-squared, which tells you the shape of it. You can just put 2 letters. I'll know what you're talking about. To graph this, because there's so many chi-squared distributions. So to graph this, we would have to know the what for the chi-squared, the degrees of freedom. Now remember, we're looking at a 2 by 2. The formula here says rows minus 1 times columns minus 1. But once again, remember, this is a 2 by 2. So how many degrees of freedom are there? So if we have a 2 by 2, we drop each finger by 1, and then we multiply, because it's rows minus 1 times columns minus 1. So you just say it's a 2 by 2. We have yes, no, that's 2. We have A, not A, that's 2, and there's 1 degree of freedom. So we're going to go over here to the chi-squared. We're going to enter in 1 degree of freedom. Then we're going to enter in R. Oh, it's close call. It's close call. But the answer is it's not statistically significant. It's towards that edge. Maybe we didn't have enough statistical power to detect the difference, but this test comes back with not... so, Kayla, what could we do if Brian said maybe we didn't have enough statistical power, goes to a theory question, what could you do to maybe detect if there is a difference? Like if Brian says maybe we didn't have enough statistical power. So what is one thing you really can manipulate to increase the statistical power of a test? So, because I could say why we didn't have enough. And the answer of why we didn't have enough statistical power is probably located with that. Take a bigger sample. Exactly. Yep. Bigger sample equals more statistical power, because power is the ability to correctly reject the false null. And the null hypothesis would be, well, we didn't write that out, is that somebody going to the reviews is independent of their grade. Like going to the review, Rock,
It doesn't matter.
your grade would not make a difference. Like going to the review is not going to impact your grade. The alternative we're looking for is that there is an association between going to the review and someone's grade. So it could be that there is an association. Our test just doesn't have a large enough sample size to detect it, because the effect size, which is the true difference from the null and the truth, well, just what the true difference is not big enough. Like maybe my reviews are helping students, but not enough. Oh no, I wanted it to be a close call, and it was. I didn't know which way this test would go. You just can't look at this though and say more people are making A's at Brian's reviews, so the reviews are helping. Let's go over here to Jump. Make sure I don't know what I've opened in Jump right now. Let me close that down. And add some data. So let's look at the... Okay, so we need to put this into Jump right here. And the way we put it into Jump is we go here to grade, and we go A, not A, not A. And then we go to review. Yes, no, yes, no. And then we go over here to count, or frequency. Might be better if we call it freak, because that's what it is. And then we have the A, and then the A who did not go, the not A, but did go to the review, and not A did not go to the review. And then we go to analyze y by x. The frequency goes here. Let's predict somebody's grade by if they attend the review. And you see there is a bit of a difference, and look at that right there. I think pretty much down to the decimal. You see this is rounding it up a little bit right here. But this is why I love doing these things in Jump right here, is you can see how finely, and look at that, Kayla, we calculated this so exactly that we got it down to the decimal of 3.516. The good news is when you run these analyses on your own, you don't have to go in and compute the p-value all by yourself. Jump down here, the p-value of 0.061 right there. Is it going to do it again? Nope. That p-value right there is the p-value right here, and we got the visualization. Is this one, how are you feeling, Kayla, on this question? Is it making more sense right here what we did, and we would not have evidence? We would fail to reject the null hypothesis. Some people might say you're close, but it doesn't matter. We don't say close in statistics. We say that does not meet our standard. Can we do some true-false review questions? Yeah, let's do some true-false here next. Casey, good to see you. Let's throw 100 points for Casey right here. But better yet, so this was a really good review of the chi-square. We probably should have written the null hypothesis to start, that there is no association, or they're independent of each other as the null, that somebody attending the review is independent of their success in Stat 1, the grade they get. The alternative being that someone attending the review is not independent. And that's the easiest way to do it, is just put the word independent between these. Attending the review is independent of someone's grade, null hypothesis. Alternative, attending the review is not independent of someone's grade, as in it would tell you something if they attend the review. That's it looks like a pretty big difference, right? Like the people who made the A's, if you attend the review, 75% of them made A's. If you don't attend the review, only 55%. That's a 20% difference, but it's probably due to sample size. That 20% difference from 55 to 75% increase is not statistically significant. Not statistically, it could be by... It is kind of right, Kayla. It's definitely... We'll do some multiple choice to end right here, but it's kind of like one big chapter of knowing how to do tests, knowing how to do confidence intervals. It's really good. This is kind of the backbone of like where we want people to get to with doing statistical tests. So let's head to the main screen. We're going to end off here with some true falses. So let's practice some Stat 201 true false. Let's see it right here. So take a moment on this screen right here. This is practice for Stat 201. All right, I'm going to try to think of multiple chapters right here. Okay. Watch me like give like 4 questions as on the test. So every one of these is a true false. So get ready, pause the screen as I do these. I'm not going to give the answers yet. I'm going to try to write 8 questions off the top of my head. You ready? 8 questions. Can Brian do it? We'll find out here. So let's try it. Okay. Question 1. What are we doing? Too big of a space. Let's put a 1. Make it easier to see which question we're on. Maybe I'll do 10 right here. See if you can get this. I'll try to do 10. That's good. One more. Stats is fun. Sounds like false. Fun is bad. One more. Gosh, why am I just stumped on one more? Okay. Kayla, take a moment. Just see what you get. I want someone to put some answers in the chat. See what you get. Oh, this chill music. So let's play one of the new favorite song. We don't play it much. Take a moment right here. I need like. There's so many things I keep thinking of adding. I wonder if I could do this as we're doing this right here. I don't know. What do you have? Do you just want to go? Do you want to go individually, Kayla? You're saying false to the first one. A value that is inside a confidence interval can be rejected on the associated two-tailed test. Boom. You got it. This is totally it right there. What we would do. When doing a statistical test, we try to prove the null hypothesis. Thoughts on this one? You can start with true or false or expand upon it. Just doing some practice here. Tell me the two things we do. What do we do with the null? What do we do with the null? What do we do with the null? What are the only two things we do with the null? So, I'll write some stuff right here while you think it over. We don't prove things in statistics. We either reject or fail to reject the null. Yeah. So we don't prove the null. The null is just what you currently believe. So like the null can be anything. The null is just a currently held belief. Whatever you currently believe is your null hypothesis. If you're like, oh, this is the null hypothesis. I do a bunch of philosophy stuff. Philosophy is kind of one of my side passions. People are like, this should be the null hypothesis. I'm like, it's whatever our current belief is. And a lot of times you can't apply it to certain things, like Bayesian analysis is misapplied a lot in historical research. Priors and posteriors, a lot of fun stuff. Ah, so now number 3. It's almost like we just go right here. What do we look for the alternative? They've turned into essay questions now. So yeah, 3 is false too. Yeah, we don't prove things. We try to find evidence for the alternative. We don't prove things in statistics. We don't do that prove thing. We don't say I proved this. We say I have good evidence to believe it. We try to find evidence for the alternative. We either continue to believe the null, so we fail to reject the null. And I like to say do not reject, but a lot of classical statisticians will say fail to reject. Once again, I do not go to the mall. I fail to go to the mall. Same thing, just different way of talking. It's like we should update our language, but it's permeated. It's gone through. It's out there, so we can't get it. We can't bring it back. There are 2 things that impact statistical power. Hey, Adam, great to see you here. There's 2 things that impact statistical power. Great job, Casey. There are 3 things. We did not include the effect size. The effect size is the true difference, or is the difference between the null and the truth. As in, so this is once again false right here. It's false because, great job. Yep. So that there's 3 things we did not include: effect size. Effect size. So I like to talk about the effect size of like being sick. When are you more likely to not figure out someone is sick? So Kayla, think about your kids, right? Oh god, no, don't think about this. This is going to talk about people being sick. When are you more likely to figure out that Brian is sick? We talked about this because I had my little fun surgery and stuff. If Brian wakes up and he's like got the sniffles, or if Brian wakes up and he can't get out of bed, which is a bigger effect size right there? Like maybe in both instances, Brian is sick. Like the null is false that Brian is healthy. So in both instances, Brian is sick. But think about the size of the effect. That's what effect size is. So the truth is Brian is sick, but how sick is Brian is the effect size. It'd be much easier to figure out Brian is sick when he can't get out of bed. Does that make sense? If I got the sniffles, it's like, maybe I don't know. I just got the sniffles this morning. Who knows? Not able to get out of bed is a bigger effect size. So that's when you would have an easier time to reject the null, which is going to get down to one of these later ones. We'll hint on that. Because that's what statistical power is. Power is 1 minus beta. More on that one. Nice job. 100 points, both of you right there. How about larger alpha will lead to more type 1 errors? Larger alpha will lead to more type 1 errors. It's so sick. Sick, man. I need to make more effects over break. I'm gonna work on that. I'll sit down some days and like it's like almost like a video game. I'll be like, what should I make today on the computer? I need to make the Nintendogs tonight. I keep talking about doing it. I just don't think there's... Let me look at that after this. We'll do that and I'll send the announcement to class after this true false. I'll see if I can... I'm trying to find a green screen of the Nintendogs. Watch it exist. So the best way to remember this one is to remember this following table. 1, 2... Don't do that. A, B, plus... minus. So type 1 error is connected to what? Type 1 error is connected to what? So 1, 2, A, B plus minus. Type 1 error is literally connected to your what? Type 1 error is literally connected to your what? So type 1 error is literally connected to your what? So if you have this table, 1, 2, AB plus minus, your alpha. So what's your feelings on this one, Kayla? Because if we know this table, we can say, well, alpha is literally connected. Like alpha is my type 1 error rate. Like alpha is the type 1 error rate. So alpha is the type 1 error rate. So what's your feelings on that? If we establish with this table right here, just a memorization technique on it, that alpha is the type 1 error rate. I know this review, but is there a possibility to go over the birth order question? I think I can send you a question on that, or I can send you, we're going to be heading off here in, because I'll be teaching soon, Landon. No, we got time. Let's go do that after this. Yeah, no, let's do that after this. I don't want to just send you a video. We'll do that one next here after we finish this. Landon, you got to hang out for a little bit here, Landon, and we'll do that one next. We got time. I'll send the announcement to 320, tell them when their class is going to start. So that way I'll do that. We started a little bit late, so we'll do that. We got this, Landon. Thank you for swinging by. I appreciate it. 100 points, Landon. Well, no, I appreciate you swinging by. That's why I'm like, you know what? I just think in my brain, I'm like, I don't want to send you a video. I want to do the work with you here. That means it's a false positive. So a type 1 error is when we reject the null and the null is true, because type 1, null is true. So it's a false positive if you think about like the null being that Brian is healthy and we reject the true null, like Brian is healthy, Brian thinks he's sick when he's not. False, I call it a false positive. You could say contextually, like if you assume someone is sick, then I don't know. In the health industry, we should assume people are healthy, because a false positive on a test would be the assumption someone is healthy, evidence that they are sick when they're not actually sick, or saying there's, we've good reason to believe they are sick. That's a false positive. So that'd be related to the alpha level. How often we reject the true null when we shouldn't, because it's an error. So the answer here is this is very, very true. It's very true. Does that make sense? So larger alphas lead to more type 1 errors, because alpha is your type 1 error rate. Does this, just know this, Kayla? Alpha is the type 1 error rate. Like if someone says, what's your alpha? They're literally telling you what % of the time they're going to make a type 1 error. So we usually make 5% type 1 errors. Yep. No worries. This is kind of a standalone chapter on statistical power and more on tests. It's chapter 16 now, maybe. So larger alphas lead to more type 2 errors. Here, let me give you some hints right here. Alpha and beta are not, which is type 2 error rate. Alpha and beta are not, they're not what's of each other. It is false. You are correct. Yep. Are not complements, but they are inversely related. So you can't say like alpha is 0.05, beta is 0.95, because there's three things that impact beta: the sample size, the effect size, and the alpha, which we're talking about here. So they're inversely related. Larger alpha would lead to less type 2 error. So this is false. So it's false right there. They're if one goes up, the other goes down. Yep, they're inversely related. As type 2 error is worse than a type 2 error is worse than a type 1 error. So, I think when you think about this one, the best way to think about it is to just think about, gosh, it's just sucky, because this is false. Yep. It really depends. Would you rather have someone say you are sick when you are not? More of a type 1 right here. Or would you rather have someone fail to find that you are sick when you are? Type 2, that's a false negative. It really depends on the person and the context. So this is as false can be. It depends on the person and the context. The errors are bad. They're both not good, but it depends. Like, would you rather have a type 1 error or a type 2 error? It depends on the context. It's not that one is always worse than the other. There's just situations where one would be worse. Like for certain companies, they might say that they'll have like a cost. Like think about a bank where they're trying to identify fraud. So a type 1 error would be when they think there's fraud, but there's not a false positive. So they're like, oh, there was fraud. So then they got to call the person. They locked the account. They could make the customer mad. And then if they're type 2, a false negative, they don't identify the fraud. So there was fraud, but they failed to find it. So with the bank, they might lose money on that. And, it's a lot of problems. So they'll usually assign a cost to it. They'll have a cost of it, and then they'll try to minimize cost by trying to figure out which errors. Yeah, so it's all contextual. Not to say type 2 or type 2 is then worse. It might be worse in that situation. In a type 1 error, we reject the true null. Boom, as true can be. Let's just write here, truth. That's the way it goes right here. True. That is true as true can be. In a type 1, we reject the true null. In a type 2, the null is false, and we fail to reject it. Remember that right there. Good way to memorize it. Statistical power is the ability to correctly reject the false null. Thoughts on this one? So thoughts on statistical power is the ability to correctly reject the false null. Statistical power is the ability to correctly reject the false null. We do try to state this. True again. Yep. Power is, and it's the formula 1 minus beta. So 1 minus beta is statistical power. So it's not making a type 2 error. So if the null is false, we should reject it. It's everything but making a type 2 error. And then when testing two means, we often assume that they have no difference. So the null hypothesis is often written out. Now, technically, you could do it where it's different, but that's the null. And true again. True again. This is the null hypothesis. We end up with a bunch of trues right here. But that is the null hypothesis. On Discord, can you let me know if I mean, I can kind of look. If you have big questions, I can't get too specific, but yeah, send it and I'll get to it. I was catching up on Discord at the start of this stream, being like, gotta catch up. I take a break from Discord some nights. I'm like, yeah, it's 7 p.m. I'm not gonna look at Discord, and then I come back and I'm like, well, we got this. Let's go do the birth order question. Good stuff, everybody. I'm going to send an email to the 320 class. Tell them their class is coming up in 27 minutes. Oh my gosh. Last Tuesday, Thursday class. Have we got an update on the extra credits? I was thinking exams. We've done this for many sections. 20 I've never heard. Who in the chat outside of our classes has gotten bonus for doing TN voice? Because I know some teachers do bonus, right? I'm like, one person is just asking if it goes against university policy. But is anyone has anyone ever gotten bonus from another class outside of our classes for doing TN voice? Because someone saying, would that go against university policy? I'm like, I don't think so. I just want to double check. Doesn't mean if other people are doing it, we're fine. But so far, 3 out of 4 instructors for 201 are like, let's do it. But I want to make sure that I'm pretty sure but just because other classes do it doesn't mean we it's totally fine. But I don't know of a university policy against doing it. Just so when someone says, is that against university policy? I'm like, I've never heard of a university policy against giving bonus for TN voice. I have not heard of that before. I have not heard of that. If there is, I'll be like, uh-oh. Stop all the presses. No bonus for TN voice. Getting the birth order question loaded up. Oh, I was going to email class, and I saw that email. Let me make sure I email the class so we can get awesome attendance today. That's what we like. That'd be a bummer if it was. Oh, go fall asleep. I gotta wake up. I'm gonna do the birth order question. Almost got all the videos labeled. 23 minutes till class. 23 minutes. 23 minutes. Oh, here we go. It's applied time series. Okay, announcements. So, class in 23 minutes. Big bonus! Click here. Okay. Double check the link. And we're going to do the birth order question. Good to go. Got this sent. Save. Go. Grace says, yes, I have. Like almost every semester, students in my introductory sixth course at a large university were classified birth order. Yeah, we're going to do the birth order one coming up here. I believe that happen every semester. Also, I think this is a great idea in case you wanted my opinion. Yeah, awesome. I'm getting a bonus from my psychology for doing it. Yeah, I think so. I've gotten a bonus before. Yeah, I've never heard of a university policy against this. And we're talking about doing some bonus. Ditto, aloha. Great to see you, Ditto. We're going to do the birth order question to end off today. Yeah, it looks like multiple people want the birth order question. Great question to end with. So, oh, of course. Yeah, of course. Of course, we're going to have some 475. You bet. Let's hop in here and do the birth order question. Here we go. Let's do it. Got all the announcements sent out, doing a little stuff in the background. You see all the beautiful things along the bottom here. So let's go check this out. We're going to talk about the competition and all the winners. Great stuff. What kind of test would we use right here? A, B, C, or no D? What kind of test would we do here for testing the birth order right here? You're welcome, Campbell. Thank you so much. Thank you for everyone who swings by. I appreciate it so much. What kind of test are we going to do right here? Thoughts on the test, the chi-squared test of homogeneity? Are we doing a goodness of fit, looking at a distribution, or the chi-squared test of independence? Well, the formula sheet's going to be a big help here if we were doing the test. Do we have it open over here? Oh, what kind of test are we doing? Chi-squared test of independence. That's the test we do. We do the chi-squared test of independence. So it is B. Great job right there. Now, what is the null hypothesis? What only word do you write? Because it's the chi-squared test of independence. So we'd have here somebody's choice of college and their birth order are going to be independent of each other. Now, they might change the wording a little bit. Independent means that there's nothing that's being, like if you know someone's birth order, it would tell you nothing about their college. So let's look at the null. So many choices, right? There is an association. That's more like an alternative right there. Is independent right there. No, Casey. No, I'm so sorry, Casey. I'm so sorry. The live button is so great. Choice of college is independent of birth order. For once, the ability to backtrack in the video got someone. I'm so sorry to hear that. And the alternative, I would like it if we just put is not independent. I would prefer that. But they are saying there is an association. So there is an association means if you know somebody's birth order, it would then tell you something about what college they are. Now, the conditions for this are 1, random, 2, 10%, 3, I usually go to expected cell count greater than 5. I'm sorry, Casey. And then 4 is going to be the count data, which means we have 2 categorical variables. Check out the review videos on this on the review page if you want to review the conditions. I do just want to give a big shout out to the review page. It's going to be in the chat here in a second. And I go through all the conditions for each one of these. They're breaking apart the randomization to a randomization independence condition. I don't do that. I just call it randomization because if it's independent, it's random. It's random, it's independent. Pretty similar. But if you go to the review page, you'll get a really good starting video. It starts with me saying, You don't get to hear it because it's muted. But if you go through this video right here, you'll learn about all the conditions and you'll go through here and you'll just go through each one and see what they mean for which test. So take some time to go through here and practice the conditions. The easiest first 2 are the random and 10%, and then going through later and getting to your expected cell count and the count data condition that there's 2 categorical variables. Awesome. Everyone's day is going crazy. So make sure to check those out right there and know the conditions. The most important one, it is count data because it's 2 categoricals. The one right here, the expected cell count, we need to check the smallest. The smallest expected cell count is going to be over here. I hate that it's this one. It's not 3 because it's 3. It's 3 because this is the smallest column. This is the smallest row. So someone could, it's kind of good because you could get lucky if you chose it to check. But the smallest column total and the smallest row total is where you can find the smallest expected. So we take the column total, doesn't matter which order, times the row total divided by this. And ooh, what do we got right here? How's that looking? How is that looking? Ooh, what do you think? What are your thoughts on this? What do you think about this? Looks like I maybe need to go back here, right? Because that's not greater than 5. 10%, is that less than 10% of all students? Probably good right there. And then randomization independence. So you've got the random condition there first. But we don't have at least 5 expected cell count. From the row total times column total over grand total, we don't have it. It's not met. Exactly. So now we go to the degrees of freedom. Say to me, Brian, this is a blank by blank. I want you to tell me, and you can look at the formula sheet right here. Brian, this is a blank by blank. Do I have the formula sheet up still? Over here. Brian, this is a blank by blank. So it's rows minus 1 times columns minus 1. Brian, this is a blank by blank. It's a 4x4. Exactly, Kayla, perfect job right there. It's 4x4. Don't use the totals. A lot of people make a mistake there. There's 4 colleges. There's 4 birth orders. So it's this right here. So it's a 4x4. Then you drop each finger by 1, 3 times 3. And Kayla got it perfect. There are 9 degrees of freedom. You just go 4x4, drop each finger by 1, 3 times 3. And that's rows minus 1 times columns minus 1. Like if you say there's 4 rows minus 1. 4 columns minus 1, and we're literally looking up here at the 4 rows and the 4 columns. 3, yep. So the answer is 3 times 3 for degrees of freedom. Great job, Grace, right there. We have here the chi-squared turns out to be 23.36. That's the sum of all the cell chi-squareds. Thus, the p-value associated with a chi-square of 9 degrees of freedom would be 0.0054. Does that p-value look high or low? They're using a 0.05 level of significance to reject the null. So that p-value is what to alpha? Low or high? The p-value is what to alpha? Is it high or low? Which one? Which way does it go? I slept pretty well last night. I think it was the night before. I get between like 5 hours to like 8 hours of sleep. And that 5 hours sometimes catches up with me. Is that p-value right here high or low? What do you think? It's low, so reject the null. So we have to reject the null. And if we reject the null, then there would be what for the alternative? So when you reject the null hypothesis, there would be evidence for the alternative because you're saying, I don't believe the null anymore. I have evidence for the alternative. This one's a bit weird right here. It basically goes to the issue of us violating the condition. Since some of the expected cell counts were less than 5, our conditions are suspect. It's probably one of the weirdest ones. They explain it a little more in depth with the residuals. We don't do residuals for this really with our calculations, but it really just goes to the violation of the condition. So they're just saying your ending results right here might have problems. And that's got a great way to end right here, getting that 100. But good question. And they're just pointing to the condition you had that's probably causing a little bit of concerns with your results. But good stuff right here. How do people feel about this problem? We'll head back here to the main screen. That's got it. Papa Shark, you've been around all semester, but we so rarely see you. Let me bring my car back here. Gotta drop my car back. Where's my car at? Oh, there we go. I need to change my... There we go. Look at that. Much better. Just gotta drive my car. Woo! Chilling out here in my car. Just hang out. I will see everybody next time. Woo! Bye for now, everybody. Bye. This is it. I'm outdoors right now. People are just standing still. They're amazed. They're saying, what in the world is going on right here with your car? I said, I don't know. It can fly. Bye. Bye, everybody. Actually, I'm meant to bring it back so that way I can drive it off at the end of 320. Bye, everybody. Really, too high. There we go. No class on Thursday. Study day on Thursday, right? Bye, Campbell. Study days. It's not a future. Well, it is a future car, but it's a past car. Bye, Ditto.